Here's the solution to day 4, problem 1. Gretchen is shrinking a digital photograph on her computer. The original photo is 4 inches by 6 inches. If she reduces the dimensions by scale factor 1/2, what will be the perimeter and area of the new image? And so to help visualize what's going on here, I'm going to draw a small rectangle. That's the original digital photograph. It is 4 inches wide and 6 inches high. Now what Gretchen is doing is she's going to transform this photo using the computer to create a new photo. She's reducing the dimensions by a scale factor of 1/2. So that means we're going to take these dimensions and multiply by 1/2. That's going to make a smaller photograph. So I'm going to draw a smaller rectangle. Now, what are the dimensions of this new smaller rectangle? 4 times 1/2. 1/2 of 4. That's 2 inches. 6 times 1/2. 1/2 of 6. That's 3 inches. With these new dimensions, we're able to find the perimeter and the area of this rectangle. So let's do perimeter first. To find the perimeter of a rectangle, you add up around the outside. So 2 plus 3 plus 2 plus 3. That adds up to 10 inches. Now the area. How much space does the photograph cover? We can find the area of a rectangle by multiplying its length times width. And so for this rectangle, 3 times 2 is 6 square inches. Now day 4, problem 2. We have these 4 arithmetic problems. Let's tackle them one at a time. Question A, -20 plus -12. This is about adding negative numbers. This number's negative, this number's negative, they're both negative. When you add them together, they will remain negative, and 20 and 12 is 32, so -32. Question B, 27 subtract -7. Sometimes it's a little hard to visualize in your mind subtraction, especially when they're negative, and so it helps to rewrite it as an adding problem. 27 plus +7. I have changed the subtraction into adding, and to compensate, I changed the -7 to a +7. 27 plus 7 is 34. Question C. Let's add these fractions together. 1/2 plus 1/4. Adding fractions are the problems where you have to have the same denominator. And right now these do not have the same denominator, so let's rewrite the fractions so that they do have the same denominator. I'm going to multiply this by 2 and multiply its numerator by 2. And this makes 2/4. So what I'm saying is that the fraction 2/4 is equivalent to the fraction 1/2. 2/4 is the same thing as 1/2. And then add, the other fraction was 1/4. We can add these because they have the same denominator. 2/4 plus 1/4 is 3/4. Now question D. 2/3 times 9/4. Multiplying fractions. Multiplying fractions, it's not necessary to have common denominators. If you do have the same denominator, that's not a problem. You can still multiply the fractions just fine. But it's not necessary to change them to have common denominators. We just multiply these together. 2 times 9 is 18. 3 times 4 is 12. But 18/12 can be reduced. There is a number that will divide into 18 and divide into 12. In fact, there's a few numbers that would divide into 18 and into 12. To reduce as fast as possible, I want to divide both of these by the biggest number I can think of. 18 divides by 6, and so does 12. 18 divided by 6 is 3, and 12 divided by 6 is 2. And so 3 halves is the answer to this multiplication problem.